Hello students, welcome to the fifth video lecture in the course Operating System. Myself Rafiqul Islam, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology under JIS Group. Till now, we have already completed module 1. So, in this lecture, we are going to study the second module, that is process management. So, this is actually our second module, that is module 2. This is actually module 2. And this is on process management. And when we discussed about the syllabus, then it is seen that in this module we have 3 parts. In this module, basically there are 3 parts. So the first part is called process. Second part is actually thread, and the third part, that is called process scheduling. Okay. So today we have to study about process and different terminologies on process. Okay. So now start about process. So at first, what is a process? What is a process? Or this is process concept. And here we have another term, that is program. Program. So what is a process? What is a program? And what is the basic difference between a process and a program? Now, consider we have written a program in C language. Suppose we have written a program in C language, and suppose it is example.c. So we have written it in C language. So after compilation, it's get converted into a machine executable code. So after compilation, it's get converted into a machine executable code and loaded this executable code into hard disk or secondary memory. So this executable code actually nothing but a.out. and it is loaded in secondary memory. Secondary memory or a hard disk. And now, in order to execute this executable code, that is a dot out, this has to be loaded into memory. So for execution, we have to load it into main memory. And when it is loaded into main memory, then the program gets converted into process. So now we can call it as process. Okay. So here we have written example.c in C language. After compilation, generates an executable file and loaded it into secondary memory, that is a.out. And if we wish to execute it, then we have to load it into main memory, and now we can call it as a process. So here we can say that a process is a program in execution. So a process is a program in execution. Okay. So this is the concept of process. Now, what is program? What is program? Actually, program, some lines of code, or we can say that it is a text or text. Okay. But process is much more than that. So this lines of code or text is just a part of a process. So the program and the process are not same. Actually, program is a part of a process. Okay. So actually, when a.out is loaded into memory, a kind of data structure is created. When a.out loaded into main memory from secondary memory, then a kind of data structure is created, and basically this data structure is called the structure of a process in main memory. So a process in memory looks like this. Now see the diagram. So basically a process in memory looks like that. So we have a text section in a process. So actually this is actually the program or the code. This is actually the program. Or code. Now we have another section. This is called data section. So in this data section contains static variables or global variables. So here we have static variables or global variables. I think all of you know what is static variables and what is global variables. Now there are another part. This is called heap section. Actually this part is used to allocate memory during runtime. So it is used to allocate memory during runtime. Okay, and we have another part. This is called stack section, where temporary data such as functions, local variables, etc. So here we have temporary data. Such as functions, local variables, etc. And this is actually heap. So there we have an upper side arrow, and this is actually stack. So we have a downward arrow. So this is actually structure of a process in main memory process. So it is actually process in main memory. So this whole thing is called process, but this part is only called program. So we can say that a program is nothing but a part of a process. Okay, I think this is clear to you. Okay, now quickly see what is the basic difference between program and process. What is the basic difference between program and process? So here we have program and here we have process. Actually, program is a static event. So it is nothing but static event, because it is loaded into secondary memory. And process is a dynamic concept. So it is dynamic concept. Main memory. Actually, in a process there are so many states. So it can changes its state from one state to another. So this is dynamic concept. What is process state and process transition diagram? We will discuss later. Number 2, obviously it resides in secondary memory and it is related to main memory. Number 3, actually program is a passive entity, passive, not active, but it is active concept. And here we have only text part, only text part, but here we have much more than that. Actually here we have text, data, heap. So here we have text, data, heap, and stack part. Already seen it. Okay. So this is the difference between a program and a process. Okay. So this is all about program, process, and difference between program and process. Okay. Now, the next topic, this is actually attributes of a process. Attributes. Attribute of a process. Actually, this is just like identity card, where we have so many attributes. Okay, so here we have process ID, we have program counter, we have process states, we have general purpose registers, we have priority, we have list of open files, we have list of open devices, and we have protection. So these are the important attributes of a process. Now see, what is process ID? What is process ID? So basically, every process will be given some number. So it is nothing but unique positive integer. Unique positive integer assigned by OS. This is actually assigned by OS in the time of process creation. In the time of process creation. So basically, operating system assigned a unique positive number for each process to identify it in the system. So this is called process ID. So actually this is just like student ID. We have unique ID number for each student. Okay, so this is just like that, process ID, positive integer number. Okay, actually this is not port ID. Okay, this is not port ID, this is actually process ID. Now next, program counter. Actually we know that program counter is a register. Actually it is register. Will contain what is the next instruction that has to be executed. So the content of this register actually next executable instruction. Content actually next executable instruction. This is program counter. Now process states. Actually a process is a dynamic concept. So in its lifetime there are so many states of a process: new, ready, running, waiting, termination, etc. Actually this part we will discuss it later in a separate section. So we will discuss this in a separate section in detail. Now general purpose register. So what is this? So basically, suppose we have a CPU and here we have so many general purpose register. Suppose this is R1, R2, R3, etc. And during its execution, a process may have some number. During its execution, a process may have some number, and which is stored in general purpose register. So suppose process P executing in CPU, so it may have some number which is stored in, suppose this is 1, 2, 3, etc. So this is called general purpose register. So a process may have some general purpose registers used during its execution. Okay. Now next, process priority. So it shows the importance of a process. So this is basically shows the importance. Okay. So whenever any process is created by the operating system, then it will generally assign something called priority. And in case of system processes, the priority is higher, but for other it is low, and it is nothing but a number. It is nothing but a number. Actually, this is a number assigned by OS. Okay, and this priority may be static or dynamic. In some particular cases, the priority may changing during runtime. Okay. Now, list of open files. List of open files. So, during the execution, some files are going to be opened. Some files are open for reading and some files open for writing. So, in a particular process, there are a list for open files. Which file is open and in which purpose, for reading or for writing. Next, list of open devices. Actually, this is hardware related. Suppose printers, scanners, etc. And have to maintain a list of this. So this is actually for files, and this is for device like printer, scanners, etc. And last, protection. So OS should protect a process from others. Okay, so this is all about attributes of a process: process ID, program counter, process states, general purpose register, priority, list of open files, list of open devices, and protection. Okay, I think this topic is clear to you. Okay, now the question is where this information are stored. We have seen various attributes related to a process. Now the question is where this information are stored. So actually, for each process, operating system creates a block called PCB. So our next topic, this is nothing but process control block, PCB, or sometimes called task control block. So basically it is a block where the each and every informations are stored related to a process. Okay, so this is just like a block, and here we have PID, process ID, we have process states, we have program counter, we have priority, we have general purpose register, we have list of open files, we have list of open devices, we have pointer to process parent, pointer to process parent, we have pointer to process childs, etc. So this is actually called PCB. Actually, a process can create many other process. That's why here use process parent, process child, etc. And for every process, there are a different PCB. So for P1 we have a PCB, for P2 we have another PCB, for P3 we have another PCB. Okay, and these PCBs are connected by a linked list. These PCBs are connected by a linked list, and when a process finished its execution, then operating system just delete its PCB from memory. Okay, so this is PCB, process control block. Okay, now go to the very important topic. This is process steps. Steps of a process. Steps of a process. A process from its creation till its completion, it will go through various states. So basically, from creation and up to completion, it go through different states, and depending on its requirements, it will make the transition. So depending on its requirement, it can transfer, it can switch from one state to another, and sometimes operating system can push it from one state to another. So this is process states, and basically in this part we have new state, So this is basically just being created, process just being created, and no resources are allocated. Here no resources are allocated. Okay, and this is secondary memory concept. New, just born, or it is sometimes called born state. Now number 2, this is called ready state. Process is ready for execution and waiting in main memory for CPU. So just waiting in main memory. So this is main memory concept. This is ready state. Processes are ready for execution. Number 3, running state. Actually, process being executed in CPU, and obviously one CPU can execute one process at a time. One CPU can execute one process at a time. So remaining ready processes must have to wait in main memory. If we have more CPU, then we can execute more processes at a time parallelly. Now, number 4, this is called block state or wait state. Block state or wait state. So here process waiting for some event to occur, such as IO wait or time slice expired. So this is actually waiting for, suppose, input output operation. This is wait state. And another state 5, this is terminate state. Here the process has finished execution and PCB will be deleted, just finished. Now we have another 2 steps. Number 1, this is called suspended ready. And another is called suspended wait. Actually, a process when moved from this ready queue, this ready state to any other backing store or secondary memory, then it is actually suspended ready. This is actually concept of secondary memory, and it is also secondary memory, but here a process when moves from this wait or block, or sometimes called suspended block, when a process moves from this block or wait state to any other backing store or secondary memory, then it is called suspended wait or suspended block. Okay, so these are the different states of a process, and a process may have minimum 4 states, that is new, ready, running, and termination. This is the simplest way from new, from creation to termination, right? Minimum 4 states. Okay, so this is all about process states. Now we have the next part. This is process states transition diagram. Process states transition diagram, which we will discuss in next lecture. So I hope this part is very much clear to you. Thank you for watching, and see you in the next one. Thank you once again.